Hello guys, hello friends, hello G's, it's your boy again, Falling with a Star. So guys, today we are going to learn about alkanes, and in our previous video we've talked a lot about alkanes, and now we are going to look at the IUPAC nomenclature for alkanes and also the chemical reactions of alkanes. So let's start with the IUPAC nomenclature. For organic chemistry, you should know how to refer to molecules by names, and these should be accepted universally by all scientists in every part of the world. You understand? And in our previous video, I talked about 3 ways you can represent what organic molecules. We have the structural formula, we have the condensed formula, also we have the skeletal formula. In order to make things easier for us, we are going to use the condensed formula and the skeletal formula to actually learn the IUPAC nomenclature. Let's look at something about the skeletal formula. I said that in our previous video, I said that every vertex and end point represents what? A carbon. So when you look at this compound here, you can see that it has 1, 2, 3, 3 carbons. This also have what? 5 carbons. You understand? One thing you have to notice is that for alkanes, every carbon is sp3 hybridized. Therefore, every carbon needs what? 4 bonds around itself. And when you look at the skeletal formula, you can see that we don't actually bring the hydrogens, but the hydrogen atoms are implied. You understand? So take note of that. So the hydrogen atoms are implied, but with this, we're not drawing these hydrogen atoms. You understand? Now let's look at the IUPAC rules. This IUPAC rules actually helps us to name organic molecules in the same way. You understand? It helps chemists, scientists to actually name organic molecules in the same way. And for alkanes, every alkane bears the suffix "ane". So every alkane will end with the word "ane". You understand? But the prefix is going to be determined by the number of carbons in the molecule. You understand? The prefix is going to be determined by the number of carbons in the molecule. So for one carbon, we have "mit". For 2 carbon, we have "it". For 3 carbon, we have "prop", and so on. You understand? So let's look at this molecule. Let's use this as an example. So looking at this molecule, you can see that it consists of what? 5 carbons. Therefore, we take the prefix "pent". And all alkanes ends with the suffix "ane". So this become what? Pentane. The same as this. This is the condensed formula, and this is the what? The skeletal formula. It's very easier to name straight chains alkanes, but that's not going to be the case always. We are going to have molecules that are going to have variety of substituents, and when I say substituents, they are smaller groups that actually branch off the main group. They are smaller groups that actually branch off the main group. So let's look at this molecule here. You can see that. First of all, let's look at how to name this molecule. In order for you to name an organic molecule, one thing you must know is that you have to first identify the longest carbon chain in the molecule. The longest carbon chain in the molecule. And when you look at this molecule, you can see that this is the longest carbon chain. And the longest carbon chain contains 4 carbons. So this becomes butane. But this is the case that we have a 1 carbon substituent here. A 1 carbon substituent here. And 1 carbon substituent is called methyl. A 2 carbon substituent is called ethyl. 3 carbon propyl. We are actually using al and not "ane" because for the substituents they have 1 hydrogen less than the alkanes. So this becomes methane, CH4, methane. But CH3 becomes what? Methyl. You understand? So this substituent here is called what? Methyl. After actually identifying the longest carbon chain, one thing you have to do is to actually number the carbons, but you can do this in 2 ways. You can actually number the carbons from left to right or from right to left. But what you have to do is that you have to number the carbons in such a way to give the substituents the lowest carbon number. You understand? So when we number these carbons from left to right, you can see that the substituent will occur on carbon number 2. But from right to left, it will occur on carbon number 3. So the best way to number it is from what? Left to right. You understand? Left to right. And in naming such molecules, you have to actually start by listing the substituents. and you list the substituent plus their location, that is the carbon they are being attached to. So when we try to name this compound, you can see that the name will be 2-methyl butane. Butane is the main carbon chain, and it's 4 carbon chain, so butane. And methyl implies that there is 1 carbon substituent, and 2 actually implies the location of this substituent. We are trying to say is that it's being found on carbon number 2. You understand? Let's look at another example. Let's look at this example here. So first thing you have to do is to identify the longest carbon chain, and this is the longest carbon chain. You understand? It's not always going to be straight like this. Depending on how tricky your lecturer is, it can go like this, can go like this. But for this one, this is the longest carbon chain. And after identifying the longest carbon chain, we have to number it. But we have to number the carbons in such a way to give the substituents the lowest carbon number. So when you look at this, it's more appropriate for us to number it from right to left, because methyl occurs on number 2, but from left to right, the ethyl occurs on carbon number 5. But one thing you have to actually note is that in case where you have multiple substituents, you actually list them in alphabetical order. So when we are naming this, we will list the substituents in alphabetical order. So ethyl will come before methyl. So let's try and name this molecule. So this will be 5-ethyl. Ethyl is on carbon number 5, so 5-ethyl, and 2-methyl, because methyl is on carbon number 2, and we have heptane because the main chain is a 7-carbon compound, so heptane. A number and a word is being separated by a hyphen. Later we will look at a number and a number, what we use to separate them. You understand? So let's look at this example. First, then you have to identify the longest carbon chain, and this is the longest carbon chain. And this is the case that we have 3 substituents here. But the 3 substituents, we have 2 methyls. 2 methyls. And in case where we have multiple substituents of the same type on a given molecule, we name them simultaneously with a prefix indicating how many they are in the molecule, like di if they are 2, tri if they are 3. So here we will use di because the methyls, they are 2. You understand? And this is the case that the di, tri, we don't take them into account when it comes to alphabetical order. So ethyl will still comes before methyl, because we use M for the methyl, not di, not D for the methyl. So let's try to name this. So now we have to number the carbons, but we have to number in such a way to give the substituents the lowest carbon number. And you can see that from left to right, this substituent occurs on carbon number 3, and this substituent is called methyl. From right to left, this substituent also occurs on carbon number 3, and this is ethyl. Because ethyl, in alphabetical order, ethyl will come before methyl, you use this direction. Understand? The direction that will give the ethyl the lowest carbon number. So let's try and name this. So this will become 3-ethyl, 4,5-dimethyl, because the methyl there are 2. So dimethyl heptane. Heptane because the long chain is a 7-carbon compound. You understand? And we use a comma to separate numbers. 4, 5 indicating that the methyls are being found on carbon number 4 and carbon number 5. Let's look at something here. Forget about the whole structure. I just drew this to make you understand certain substituents that actually use common names. They don't follow the IUPAC rules. So this is called isopropyl. Propyl because this is a 3-carbon alkyl substituent. A 3-carbon alkyl substituent. And iso is regard to the shape. It's regard to the shape. You understand? So this structure is called isopropyl. And this is called tet-butyl. This is called sec-butyl. And this is called isobutyl. In order for you to understand the reason why I'm using tet and sec for these two, we have to look at something here. we have three types of carbons. We have primary carbon, secondary carbon, and tertiary carbon. And for primary carbons, the carbons are connected to only one carbon. So for this is a primary carbon. Understand? This is also a primary carbon because it's connected to only one carbon. So this is connected to only one carbon. Secondary carbons, they are connected to 2 carbon atoms. Tertiary carbon, they are connected to 3 carbon atoms. So this is a tertiary carbon because it's connected to 3 carbon atoms. So let's take a look at these two. You can see that when you cover this, you can see that the carbon that is actually connected to the long chain, that carbon is a secondary carbon because it's connected to 2 carbons, and that's why we call it sec-butyl. Same implies for the third butyl, because the carbon connected to the main chain is connected to 3 carbons, which is 1, 2, 3. You understand? Yes. So now let's look at the chemical reactions for alkanes. Because alkanes are saturated hydrocarbons, they are chemically unreactive due to the high bond enthalpies and low polarity in alkanes. They do not react with strong acid, bases, oxidizing and reducing agents. So they are sometimes referred to as paraffins because they have slight affinity for other compounds. But alkanes can undergo 2 main reactions, and they are halogenation and combustion. Let's look at combustion. Combustion is a reaction with oxygen. It's a reaction with oxygen, and we have 2 types of combustion. We have complete combustion and incomplete combustion. For complete combustion, the alkane will react with oxygen and will produce carbon dioxide and water. For every alkane in complete combustion, we produce carbon dioxide and water. So methane, ethane, propane, they all gives carbon dioxide and water. So methane and this oxygen, see, carbon dioxide and water. Let's look at incomplete combustion. For incomplete combustion, there is the production of either carbon or carbon monoxide plus water. The carbon or carbon monoxide will depend on your choice. You will be the one to choose. So the alkane plus oxygen, you get carbon and water, or carbon monoxide and water. This is for incomplete combustion. Now let's look at the halogenation reaction. Halogenation reaction is just a reaction with halogens like chlorine, bromine, and fluorine. And here, because alkanes are saturated, in order to add an atom, you have to remove a hydrogen atom in order to add an atom to the alkane. So it's more of swapping. So you swap one hydrogen for the halogen. So when you look at this, you can see that we've swapped one hydrogen for the halogen, and there's production of an acid, which is HCl, and this is being done by the help of ultraviolet light. All these actually occurs in 3 steps, and these steps are called the free radical mechanism. And in the free radical mechanism, we have the initiation step, the propagation step, and the termination step. You understand? The initiation step, the propagation step, and the termination step. And for the initiation step, this is where the halogen is being splitted into 2 free radicals. And free radicals, they are being represented by a dot, meaning they have an unpaired electron. And this splitting is being done by ultraviolet light. And this kind of splitting is called homolytic fission. Homolytic fission. Lytic means split, and homo is because we are splitting 2 carbons of the same kind. You understand? Yeah. So in the initiation step, this is what happens. The propagation step, the termination step, I'll not go into much details. So let's look at this example 2. You can see that this is ethane reacting with bromine gas. You understand? And you get this and this. This is an acid. And an alkane with a halogen is called haloalkane or alkyl halide. Thank you.